Right now, you are sitting still. You feel nothing pulling at you. The floor holds you up, the air holds you gently, and the sun outside your window looks small and calm, like a coin stuck in the sky. But that calm is a lie. That coin is a furnace 1,000,000 times the size of your entire planet, and if you ever fell toward it, your body would not die the way you imagine. It would die stranger. It would die slower, then impossibly fast, then in a way physics still struggles to describe cleanly. Think about how far away that coin actually is. 93 million miles. Light itself, moving faster than anything in the universe, takes over 8 minutes to cross that gap. So, the sun you're looking at right now is not the sun as it is. It is the sun as it was 8 minutes ago. You have never once, in your entire life, seen the present sun. You have only ever seen its past. Keep that in mind, because everything about to happen to you will unfold across a distance so vast that your entire concept of far away barely applies. Let's begin at the edge, 3 million miles out. This is where the sun stops being a picture and starts being a place. Here, space itself is already screaming. Solar wind, a stream of charged particles moving faster than a bullet, hits your skin first. Your spacesuit boils. Not from touch. From radiation slamming into every atom of the fabric until it glows, then blisters, then fails. This is the same wind that, back on Earth, gets funneled toward the poles by the planet's magnetic field and lights up the sky as an aurora. From a distance, it is beautiful. Up close, it is a firing squad made of particles. Carl Sagan once said the sun is a mediocre star in an average galaxy. Mediocre, not special, not rare. Just one of roughly 200 billion stars in the Milky Way, and the Milky Way is just one of hundreds of billions of galaxies. And this mediocre star could still erase you before you got anywhere close to its surface. Imagine what the ones astronomers call extreme could do. You keep falling. Gravity does not care what you think you deserve. It only cares about mass and distance, and the sun has enough mass to bend the space around it like a bowling ball dropped on a bedsheet. Albert Einstein figured this out over a century ago, in 1915, and it changed how humanity understood falling forever. Gravity, he said, is not really a force. It is geometry. It is space itself curving, and you are simply rolling downhill along a slope you cannot see. Here is the unsettling part. You would not feel yourself accelerating. Not at first. In free fall, you are weightless, the same way astronauts float inside the International Space Station. There is no sensation of falling, only the sensation of being still while the universe rearranges itself around you. You would feel calm. Your instruments would show you were dying. Which one do you trust? By the time you are close enough for the sun's gravity to truly matter, you would already be moving at over 130 miles per second. Faster than any spacecraft humans have ever built has traveled toward a star. Faster than a bullet fired from the fastest rifle on Earth, multiplied by 100. At 100,000 miles out, the temperature climbs past anything on Earth. The hottest deserts you know reach perhaps 130 degrees Fahrenheit. Here, you are already past 10,000 degrees and climbing. Your suit is gone now. Your body is exposed to plasma, matter so hot that electrons are ripped clean off their atoms. This is the fourth state of matter, the same state that makes up over 99% of everything visible in the universe, and it does not care that you are made of carbon and water and memories. Should it? Solid, liquid, gas, plasma. You learned the first three in school using ice, water, and steam, but almost nothing in the cosmos actually exists in those familiar states. Stars are plasma. Lightning is plasma. The interior of every galaxy, glowing between the stars, is plasma. You have spent your whole life as a strange exception, a rare pocket of solid matter, in a universe made almost entirely of something you have barely ever touched. 10,000 miles out, something else begins. Spaghettification. It sounds almost funny until you understand what it means. The gravity pulling on your feet is now dramatically stronger than the gravity pulling on your head because your feet are closer to the sun's core. The difference stretches you. Slowly at first, then all at once. Stephen Hawking spent decades studying this exact kind of gravitational extreme near collapsed stars. Black holes so dense that not even light escapes them, and the math does not change just because the sun has not collapsed yet. Tidal force is tidal force. Your body becomes a thread. Around a black hole, this process happens in an instant, a violent snap at the edge of the event horizon. Around the sun, because it is far less dense than a black hole, the stretching is slower, almost gentle in comparison. Gentle is the wrong word for something that eventually tears you apart atom by atom, but relative to a black hole it is practically merciful. The universe has scales of horror you have not even imagined yet, and somehow falling into the sun is the mild version. Your blood, which is mostly water, would begin to boil at these pressures despite the intense heat, because pressure and boiling point are linked in ways that would seem to break the rules you learned in a kitchen. Nothing about this death follows kitchen rules. Nothing about this death follows any rules you already know. But you never actually reach the surface. Not really, there is no surface to reach. The sun does not have a hard shell like a planet. It has a boundary called the photosphere, a layer where plasma becomes dense enough to stop being transparent, dense enough to finally emit the light you see from 93 million miles away on a quiet afternoon. Beneath that boundary is not solid ground. It is a churning ocean of plasma, layer after layer, growing hotter and denser until you reach the core, where temperatures hit 27 million degrees, and hydrogen atoms are crushed together so violently they fuse into helium, releasing the very energy that has been warming your face your entire life. This is nuclear fusion. Two hydrogen atoms merge into helium, and in that merger, a tiny fraction of mass converts directly into energy, following the same equation a young Einstein scribbled down decades before anyone confirmed it. Energy equals mass times the speed of light, squared. That squared term is why so little mass produces so much power. The sun converts roughly 600 million tons of hydrogen into helium every single second. Every second. It has been doing this for 4.5 billion years, and it has enough fuel to continue for roughly 5 billion more. Edwin Hubble spent his career pointing telescopes outward, cataloging galaxies fleeing from each other, but even he relied on starlight, the very light produced by this exact process, to measure the universe at all. Every photon reaching your eyes tonight left a fusion reaction like this one. Sometimes millions of years ago, born deep inside a stellar core and taking, on average, tens of thousands of years just to fight its way out to the surface before finally escaping into space. That photon warming your skin on a summer afternoon began its journey before humans had invented writing. You are not just falling into a star. You are falling into the engine of everything you have ever seen. By now, your body no longer resembles a body. The atoms that once made up your bones and skin are simply particles again, stripped of shape, absorbed into a storm of plasma 100 times denser than water at the core. There is no scream. There is no final moment of clarity. There is only conversion. Matter becoming energy, energy becoming light, light eventually leaving the sun and traveling 93 million miles to warm a face that is not yours anymore, because it does not exist anymore. Here is the strange part. In a sense, this already happened to you. Every atom heavier than hydrogen in your body was forged inside a star that lived, burned, and eventually died in an explosion far more violent than a quiet fall into the sun. Your calcium, your iron, your oxygen, all of it was once inside a stellar furnace just like this one, billions of years ago, in a star that is no longer there. Carl Sagan called this being made of star stuff. It was not poetry, it was chemistry. The iron in your blood, the calcium in your bones, the oxygen you just breathed in without noticing. None of it came from Earth originally. It came from a star that exploded long before our sun ever formed, scattering its ash across a cloud of gas and dust that eventually collapsed to build our solar system. You did not arrive on this planet from somewhere else. You were built, atom by atom, from the wreckage of a star that died so that you could exist. So, in a sense, falling into the sun would not be an ending at all. It would be a return trip. So, what would you actually feel falling into the sun? For the first stretch, terror and heat, and the horrifying awareness of your own suit failing around you. Then, as spaghettification takes hold, something almost worse than pain, a slow unraveling, a body forgetting how to be a body. And then, past the point where flesh can exist, nothing you would recognize as feeling at all. Just atoms, joining a process older than the Earth itself, older than the Moon, older than almost everything you have ever loved. The Voyager probes, launched in 1977, are now billions of miles away, moving in the opposite direction, carrying golden records of human voices and music into the dark, outward, away from stars like this one. They will likely outlast the sun itself, drifting through the galaxy for billions of years after Earth is gone, carrying a message almost no one will ever hear. There is something strange about that. Humanity's furthest reach is defined by moving away from stars, while every atom in your body was built by falling into one long before you were born. In roughly 5 billion years, the sun will swell into a red giant, hundreds of times its current size, and it may consume Mercury, Venus, and possibly the scorched remains of Earth, finishing the very process that would have consumed you if you fell in today. The star that keeps you alive is also eventually an ending, not just for you, for everything. And yet you are here reading this, made of the same atoms that once burned inside a star exactly like the one outside your window. You are not separate from it. You never were. The sun is not just a light in your sky. It is the reason you have a sky to look up at. The reason there is a you capable of wondering what falling into it would feel like in the first place. Right now, you are sitting still. But somewhere above you, 93 million miles away, the process that built every atom in your body is still running, still fusing, still burning, patient enough to wait 5 billion years to finish what it started the moment you were born from its light.